Hello everyone, I'm Emma. And today I'm going to talk about the influence of sex and maturity on the diet, mouth morphology, and dentition of the Port Jackson shark, Heterodontus portuskacksoni. In the introduction of Heterodontus portuskacksoni, they are a kind of benthic shark. This means they live on the surface of sediments, and they live in the coastal water and are abundant in the coastal of temperate eastern Australia. And since they're living in the coastal water, we want to know if their diet varies from sex and maturity. And these are the two most important points we'll discuss in this study. And the hypothesis is that scientists assume dietary could be influenced by sex and also maturity. And there is a very wide variety in the composition of their diets. 32 kinds of prey items are included. And on this slide shows the prey items they constantly consume. And we can roughly divide them into two groups, something hard and the other soft. So in this study, we are going to discuss whether maturity and gender make a difference in their selection of food type. And going to material and methods. So they got 136 male and 100 female of Heterodontus portuskacksoni from Newcastle, New South Wales, Australia. Time ranges from July 2004 to March 2005. And after capture, individual sharks were then frozen and stored at minus 20 Celsius degree until later dissection and the removal of their stomachs. In this table shows the data of the sample's body length and their quantities. Blue represent male and red represent females. And we can divide their maturity stage into three groups from their body lengths. Juveniles means boys and girls, and superadults means teenager, and there are adults. We enter experiments. So first, take the sharks out of the freezer, and they take out their stomachs, open them, and put the stomach contents on a 1 × 1 millimeter mesh, and then rinse under the running water. So that food items that are identifiable will retain on the mesh. For food items that are unidentifiable, we'll then collect it and put into 10% formalin for 48 hours to fix, preventing them from rotting, and then be preserved in 70% of ethanol for later identification. And results of stomach contents. So there were 236 stomach examined and 191 contained food. In all stomachs, there are 64.4% of stomach contain identifiable food or were empty. And there are 35.6% of stomachs contain well-digested food. To total prey weight, there were 96.7% of identifiable food and 3.3% of well-digested food. Now look at here. Well-digested food occurs in 35.6% of all stomachs, but only account for only 3.3% of total weight. That's very, very few. And then they divided the fullness of stomachs into 5 grades, from 0 to 4, as this 5-point scale shows here. And the mean stomach fullness is about 1.8 here. And this chart shows the number of food type in the stomach contains. There are 38% of stomachs contain just single prey item. 20% of stomach contain 2 different kinds of prey items. 9% contain 3 different kinds, and 4% contain 4 to 5 kinds, and there are 29% of stomachs were empty or just contain something we can't identify. In all the stomach contents, they found that teleosts and decapod crustaceans take the majority of their diets. They happen in 50.6% and 36.3% of stomachs, respectively. And after comparing stomach contents of 2 different genders, they find there were significant differences between male juveniles and female juvenile diets. So look at this table. Female juveniles consume crustacean the most, about 5.29 contribution percentage, while male consume only 0.87 contribution percentage. And the prey item that male juveniles consume the most was Ophiuroideae. It's about 2.42 contribution percentage, while female juveniles didn't even eat them at all. And there is no significant differences between diets of male and female in the maturity stage of subadults and adults. And let's examine the diet composition at different maturity stages. In this table, you can find that diets of juveniles and diets of subadults are similar. But it seems that adults prefer to eat fast-moving prey, such as octopus and fish, and this directly related to their capture ability and their body size. Discussion. So from this table former mentioned, we know that there were significant differences between diets of male juvenile and female juveniles. This may be caused by different range of activity areas. Juvenile of both sexes are sampled in the same nursery area, but the female-based sex ratio of this nursery area is 2 to 1. This means male juveniles are twice as many as female juvenile in this area. The possible reason may be that males may range over a broader area than females, and this may enable them to access more prey items. And the discussion of diet shift related to maturity. Prey of juvenile and subadult are usually benthic prey. This kind of prey usually live on the seafloor or inside the sediments, while prey of adults are usually pelagic prey. Pelagic means this kind of animal live in the water layer, such as fish, and this kind of prey are often bigger and faster. And we know that food prey items that were selected were those most able to be captured, so that maturity affects selection of prey by mouth size, body size, and also swim speed. And the intermittent feeders. These 2 figures are about the results of stomach contents we formerly mentioned. And you can see here is 96.7% of the total weight is identifiable food, and we can even count how many types of food there are. And this happens in over 60% of all stomachs. So this indicates that Heterodontus portuskacksoni is one of the intermittent feeders. This kind of feeders has a very short feeding period and spend most time digesting their food. This often happens with predator because hunting is very energy intensive. So they focus on good digestion and try their best to absorb all the nutrients completely. And in comparison, continuous feeders are typified by stomach with multiple food items at different stages of digestion and few empty stomachs because they are eating all the time. So the conclusion of this study. First, maturity stage show the highest influence to diets. Second, body size and swim speed related directly to the selection of food prey and cause the variation of diets in different maturity. Third, such wide diversity of prey items shows that Heterodontus portuskacksoni performs an important ecological role on the nearshore reefs. So that is my presentation. Thank you for your listening.
Okay, thanks for your presentation. I think the major improvement of your presentation is that you make lots of figure by yourself, like the charts, the tables. It's made me very easy to follow what's your like experiments and the result. I think it's quite good, and you add lots of figures about creatures. I think it's very easy to understand, but the word is still a little bit uh, small, and the terms is too hard. Maybe you can explain some vocabulary more. Yeah, and the conclusion slide. There's a conclusion that you haven't mentioned in your experiment. So maybe next time you can remove it and make a font a little bit larger. Okay, thank you.
Okay, thank you for your presentation. I think you you lost some unnecessary slide or images and focus on the most important in this study. So it's a great improvement in your time control. So it's better than your previous talk. Thank you.
Okay.